Wrapping up our selection of examples for Section 2.6% problems, we've got the following mixture problem. We're told that a chemist has some 12% hydrogen peroxide solution and some 9% hydrogen peroxide solution. How many milliliters of each should be mixed to make 450 milliliters of a solution that is 10% hydrogen peroxide? Well, the model, anytime we come up with a mixture problem like this for a mixture, the quantity of the substance in question, in this case hydrogen peroxide, in a solution, we assume a solution mixed with water, is going to be the actual amount of the solution times the percent concentration in that. So this is our model that we want to have in mind whenever we're dealing with this kind of mixture problem. Well, what do we do? Well, it seems like, they're not telling us how much 12% hydrogen peroxide solution, how much 9% hydrogen peroxide solution. But this is a job for setting up a table, so that's what we're going to do. We're going to set up a table that represents each part of our mixture. So along the very first column, we'll just label, we'll say, well, we've got a 12% solution somewhere here, and we've got a 9% solution. And when we put those two together, we're going to end up with a 10% solution somehow. So what do we put right here? Remember that if we're putting together a table, we're using this formula up here to help us organize it. And so we're going to want to know A, which is the amounts, the actual amounts of the solution that we have. We're going to be multiplying that by R. R is our percentage concentration. Right? And that's going to give us our Q, quantity of the substance within the solution, the actual quantity of each of those. Well, what do we know? At 10%, we want 450 milliliters altogether. Well, remember, in this case, we always add down the columns and multiply across. And if we add down this column, that means that whatever amount we put at 12%, we're going to have to add whatever amount we get at 9% to get a total of 450. So we've got X milliliters of our 12% solution. What does that mean for our 9%? Well, whatever X is, it'll be that much less, 450 minus X milliliters of the 9% solution that we add up. Remember, X and 450 minus X must add up to 450 to give us that total amount. For our percentage part of the concentration, our values for R, we have to put the decimal form of each of these values. Of course, 12% is 0.12, 9% is 0.09, and 10% is 0.1, or just 0.1. So what do? Well, we're going to multiply across. Right? In our table, we use this formula to help us organize what we know, and we're going to have X milliliters of our 12% solution times the percentage of hydrogen peroxide, and that's going to give us 0.12 times X milliliters of our hydrogen peroxide, the actual amount of hydrogen peroxide in the solution. Same thing right here. We're going to take the quantity of 450X and multiply that by our percentage concentration of 0.09. So it will look like 0.09 times 450 minus X. Now those quantities should add up, and we're going to end up with the amount of concentration in our mixture, which is 0.1, 10% times 450. Well, the nice thing about this table is that we have our setup all ready to go. Right? We add the first two rows of the last column together to get the amount in the last column. So we end up with 0.12 times X plus, we say plus 0.09 times 450 minus X milliliters, and that will equal 0.1 times 450. 0.1 times 450 is really easy, by the way. We just move the decimal place back over 1, we get 45. Right? If you need help on that, you can think 450 times 0.01. Right? 450 times 1 is 450. We don't need to multiply anything by 0, but we know that we have 2 decimal places. So if we move that over not 0.010, 0.1, we have 1 decimal place to move that over. That's going to be 45.0, so 45. All right, let's work through the problem. We're going to take 0.12x plus 0.09 times 450 minus 0.09x will equal 45. Well, we need to do a little bit more simplification. Let's work this out. If we take 450 times 0.09, what's going to happen? Well, 0 times 9 is 0. 5 times 4 is 45. We carry up the 4. 4 times 9 is 36 plus 4 is 40. We have 2 decimal places right here. We don't have to multiply everything by the zeros to know this. We just move that decimal place 2 places to the left, and that gives us 40.5. So our equation now looks like this. 0.12x plus 40.5 minus 0.09x is equal to 45. Let's simplify one more time. 0.12 minus 0.09. Well, let's see. There's a difference of 3 between 12 and 9, so 0.12 minus 0.09 is going to be 0.03 times x plus 40.5 equals 45. Doing our subtraction right here, we subtract 40.5 from both sides. My pen has this tendency to leak when I hurry through a calculation, but bear with me. 0.03 times x is equal to 45 minus 40.5. Do the subtraction right there, and you get 4.5. So now we have to divide both sides by 0.03. So we're going to divide by 0.03. And we're going to find that x would equal the fraction 4.50 divided by 0.03 if we want to eliminate. The decimal. That means that what we're going to have to do is we're going to have to move that decimal place over twice. So we move it twice on the bottom, twice on the top. So this is really like saying 450 divided by 3. Okay. 3 goes into 450. Well, 3 goes into 45 15 times. So we're going to say x is actually equal to 150. Well, this gives us our answer, because this is going to tell us that we're going to use 150 milliliters. Of our 12% solution. And let's see, 450 minus 150. I'll even work this off on the side. 450 minus 150 gives us 0, 5 minus 5, 0, 4 minus 1, 300. So we're going to have 300 milliliters of our 9% solution to add with that to get our 10% solution. That's our answer. Don't forget to use proper units whenever you answer these mixture problems. Good luck.